let's see what we can do here. Okay, number one. This one looks like it is basically a power rule for every single one of these problems, right? Power rules. There's no trig in there, right? There's no trig. There's no quotients, right? We don't have any derivatives or functions in a denominator. So number one looks like it's a straight up power rule derivative. So let's go one term at a time. The derivative of 2x cubed is 6x squared. The derivative of x squared over 5 is 2/5 of x to the first power. And now, what do we get when we multiply 3/4 times 4? We just get a 3, so that's 3x to the negative 1/4 power, right? 3/4 minus 1, or 4/4, is negative 1/4. And then the derivative of 6e to the third is minus, well, actually, guys, that's 0. Because e is a constant. There's no variable in there, is there? Right? These e ones are tricky. This is a number, not a very nice number. We don't really deal with e value, e numbers, but this is a number, right? There's no variable in there, and the derivative of a non-variable is 0, right? Because it's constant. It has a constant slope. So then we can do one other thing here, and that's rewrite our negative fraction as a denominator. Okay, so we can bring this negative 1/4 to be a positive 1/4 if we move it to a denominator. And then we can, instead of having a 1/4 power, we can make this into a 4th root of x, right? So that would be a complex number there. I'm going to erase this and make it look prettier. So that would be good enough as our derivative, right? So we can use the derivative to find the slope of the tangent line at any given value of x. Okay, so that's where we're going to head with this, is finding the tangent lines by using our derivative to find the slope. Okay, let's go with number 6. Let's go across. This is, well, the trig. So with trig, we have to use what rule? The chain rule. Every time we do a trig derivative, we're going to use the chain rule. Okay, so first, we're going to do what with our power? The power comes to the front, right? So we're going to use the power rule with our power. So that will be 5 in front of our cosine to the 4th of x. And now we multiply it by, what is the derivative of cosine?
Negative sign.
Negative sine. Of x. So this can be negative 5 cosine to the 4th times sine x. Okay, let's see, what else do we have? Maybe these ones, oh, how do you want to tackle number 2? Right, because there's a couple ways we could do it. We could use the quotient rule for sure, right, because there's a function over a function. Or we can change this to be a single polynomial and write it using the power rule. Okay, now my druthers, and you can have your choice also, would be to change this into a single polynomial before we take the derivative of it. Okay, so I'm going to rewrite g as a single polynomial. So I'm going to take this fraction, 3x cubed over x squared, reduces to be just 3x, right? There's x cubed on top and x squared on bottom. those simplify to just have an x on top. Okay, and then we have these guys. 4x squared divided by x squared is just the number 4. And then we're going to have these as our third fraction. Negative 5 over x squared becomes negative 5x to the negative 2 power. Okay, because I would rather not have any fractions in my problem when I start to take a derivative. Okay, so x to the minus 2. It was an x to the positive 2 in the denominator, and our rule says, or our property, it means you bring your power to the top and make it a negative. So if that's g is much simpler now. We can take the derivative pretty easy, maybe. So the derivative of 3x is 3, right? Just the slope. And then negative 2 times negative 5 is plus 10x to the negative third, right? Because we subtract 1 from the exponent. So finally we can take our x to the negative third and put it back into the denominator as something like this. Now, in case you were seeing a multiple choice AP test, they might write it like this once we have a common denominator of x cubed. So that means we're multiplying 3 by x cubed over x cubed so that we have a fraction that we can add to this fraction, making this the answer also, right? These are both good answers. But this is the way you might see it on a multiple choice style test. Okay, number 3, what rule shall we employ? The product rule, very good. This is a product of two different functions. It's an x cubed function times a trig function. So product rule is ab prime plus a prime b, right? You can put it in any order you want to. We're adding them together. The order doesn't matter, but just to stay consistent. So a prime b means we have our first equation just like it is. So that's x cubed times the derivative of secant, right? The derivative of the second equation. And the derivative of secant is secant tangent. Okay? Plus the derivative of h cubed is 3x squared times secant, right? So it's multiplied by the second term right there. Okay? And that's good enough. We could leave it like that if you would like to do that. Okay, so x cubed times secant times tan plus 3x squared times secant. Now the problem is multiple choice probably won't do that. So looking at our two terms, what do each of these two terms have as a common multiplier? They have at least x squared, right? One has x cubed and the other one has x squared. So they have x squared in common. What else do they have in common? They have secant. So because they have both of these things in common, we can factor them out. Okay, leaving me with x tan x plus 3, I believe, right? The x squared is gone, the secant is gone, only 3 is left. And that looks really horrible, so I'm going to redo it. There we go. That's better. So there's your commonalities, right? This is what they have in common as multipliers. And then this is what's left over. Okay, taking derivatives. Okay, number 4, 5x to the fourth times the tangent of 2x cubed. Once again, this is a product rule. So we're going to do this function times that function. Okay, so anytime we do a tan derivative, this is going to be a chain rule, only applied to our tangent derivative. Okay. 5x to the fourth, that's not a chain rule derivative. We will leave that one as it is. But anytime we take the derivative of tan, we're going to be using the chain rule. Okay, let's do it down here. Y prime, our function is y, so our derivative is y prime. Chain rule, product rule says we leave the first thing alone. So 5x to the fourth times the derivative of the second thing. So let's do this one part at a time. First we deal with the trig. What's the derivative of tan? Secant squared of 2x cubed, right? That's the argument of our trig function, 2x cubed. Okay? So now that we've taken the derivative of tan, we have to take the derivative of 2x cubed, which is 6x squared. So that's the whole entire thing. That is the derivative of tan 2x cubed. All right, all three of those things. Plus, what's the derivative of our second term? 20x to the third power. And we multiply that by tan of 2x cubed. Okay, let's jump up here to number 7, right? So this is a trig one, which is going to be another chain rule derivative. Okay, and usually when we do a trig, especially when there's parentheses and like this fourth power, right, you're going to know that we're going to be doing the chain rule. So let me make a different color so we can see this. Okay, y prime equals, first we deal with the fourth power. Okay, so we could also write this as the secant of 3x squared, all raised to the fourth power. Right now, maybe doing this might make it easier for us to see exactly what we're going to do using the chain rule. So first we're going to employ the power rule and bring our 4 to the front. Okay, so we're raising something to the fourth power. It's secant to the fourth. So we're going to raise this secant of 3x squared now to the third power. Okay, in a second, once we're done, if you want to, you can put it back there in between secant and its argument. But it is perfectly happy hanging out way up there on its golden perch. Okay, so now that we've done with the power, we have to deal with the derivative of secant. Okay, so the derivative of secant is secant tangent, right? And the argument doesn't change, so it's still 3x squared and 3x squared. Okay, so that is the secant part. We just took the derivative of secant. And we leave the argument, whatever the argument, right? This is a pretty complicated argument, 3x squared. It's just showing up everywhere. And now our last thing to do is take the derivative of our thing in parentheses. So what's the derivative of 3x squared? 6x. Okay, so we have this really, really long, pretty complicated looking derivative where the only thing we can really do to simplify, I guess we can do lots of things, but I don't think we're gonna. You could take your 4 and multiply it by the 6x. Right, that might be one thing that we could do to make this into a 24x. That would be appropriate, 24x. Okay, let's get a little bit more crazy, shall we? Okay, here I have how many secants? Here I have 3 secants, and then I have another secant. So how many total secants do I have? I have 4 total secants. So I can write that as secant to the fourth of 3x squared. Okay? Remember, this is all multiplication, which is why I'm able to do that. I have secant to the third power, and I have secant to the first power. 3 plus 1 is secant to the fourth. And then my last thing that I have that I haven't touched yet is my tan of 3x squared. Okay, now this right here is a perfectly good thing. You can leave your answer just like that. That is 100% correct. You've done a great job of the chain rule derivative, but this is how you might see a multiple choice style question, right, with it being simplified. That's the only difference between the two equations. Okay, we've got time for one more here, my lovelies. So let's do number 8. Okay, we haven't done a quotient rule one yet, but this is definitely a quotient rule derivative, right? Low D high minus high D low over low low. So let's start right here. F prime, we'll squeeze it in here. Low D high minus high D low over low low. So our low function, your denominator is x times the derivative of sine of 2x cubed. Right? When we take the derivative of this, we're going to use the chain rule. So we start off with what's the derivative of sine? So derivative of sine is cosine of 2x cubed. And now what's the derivative of 2x cubed? 6x squared. So that's all for the derivative of cosine, low D high. Okay, that's all for sine of 2x cubed, all three of those parts. Minus the high equation, which in this case is sine of 2x cubed, times the derivative of x, which is just 1. So that's pretty nice, over x squared. Okay, and you know what? That is good enough. The only thing you could do is maybe multiply this 6x squared times that x to get you a 6x cubed, but that would be the only thing we could do to simplify these equations. Okay? There we go. A little bit of derivative taking, okay? Because it's important to know how to take a derivative.